LiveLongBench is a new research paper that addresses the challenges of understanding long contexts in spoken texts, particularly those from live streams. The paper, titled LiveLongBench, Tackling Long Context Understanding for Spoken Texts from Live Streams, is authored by Yongxuan Wu, Runyu Chen, Peiyu Liu, and Hongjin Qian from the University of International Business and Economics and the Beijing Academy of Artificial Intelligence. Spoken texts, like those in dialogues or live streams, are common in everyday scenarios, such as conversational AI and real-time communication. According to the paper, these texts have unique properties, including high redundancy with repetitive phrases and filler words, as noted in earlier studies like Eisenstein's work from 2013. This redundancy creates computational challenges, increasing processing overhead and making semantic understanding difficult for large language models, or LLMs. While LLMs have shown impressive results on various benchmarks, most existing datasets focus on written texts and don't capture the informal, redundant nature of spoken language. This limits their usefulness in real-world applications. To fill this gap, the researchers introduce LiveLongBench, the first dataset specifically designed for long context understanding of spoken texts derived from live streams. The dataset includes texts in both English and Chinese, with sequences averaging around 97,000 tokens. This makes it significantly longer and more complex than many other benchmarks. The paper compares LiveLongBench to other datasets in a table, highlighting differences in attention span, language style, and average word count. For instance, it stands out with its focus on spoken texts and global semantic understanding, unlike benchmarks like LongBench or InfinityBench, which emphasize written texts. To evaluate LLMs on this dataset, the researchers designed 9 distinct tasks across 3 categories: retrieval-dependent, reasoning-dependent, and hybrid tasks. Retrieval tasks involve finding specific information within the long context, such as locating details in a stream of redundant speech. Reasoning tasks require deeper analysis, like inferring conclusions from conversational data. Hybrid tasks combine both, testing models on mixed scenarios that mimic real-world live streams. The paper raises 2 key questions. First, can base LLMs effectively process long-spoken texts with their informal characteristics, including filler words like and Second, can existing methods achieve higher compression rates, perhaps by combining techniques, to handle the redundancy more efficiently? In their experiments, the researchers evaluated popular LLMs and specialized context compression methods. They found that current models show strong preferences for specific tasks but perform poorly on highly redundant inputs. No single method consistently outperformed the others, revealing limitations in handling the unique patterns of spoken language. For example, LLMs often struggle with the lost in the middle phenomenon, where important information in the center of a long context gets overlooked, as discussed in recent studies like Liu et al. From 2024. Additionally, redundant tokens waste computation by expanding the key value cache, which stores information for processing, leading to higher memory and latency costs. To address these issues, the researchers propose a new baseline method that better handles redundancy in spoken texts. This approach achieves strong performance across the tasks by using more aggressive and selective context compression strategies. Their findings highlight the need for future improvements in long context understanding, such as developing techniques tailored to spoken language's informal traits. The paper emphasizes that LiveLongBench fills a critical gap in evaluating long context spoken language understanding and provides a practical foundation for applications like real-world e-commerce systems, where live streams are common. Overall, the results from LiveLongBench show that while LLMs are advancing, they still have weaknesses in processing redundant, conversational data. This benchmark, with its code and dataset available on GitHub at the link https://github.com/yaraics/livelongbench, offers a valuable tool for researchers to build and test more robust models for spoken text scenarios.